Hello everyone. I'll be talking about the very last section of the chapter 7 straight line graphs in this video. So in the previous videos I already discussed about the application actually. So I want you to watch that one first before you go through here. And then how you convert from a nonlinear equation to linear form. So now let's move on to the final part. So how do we do it the other way around? You're given a particular linear form, but then you need to convert it to a nonlinear equation, which basically it's like sometimes it's the other way around. So sometimes we need to do this one first, but in some cases we need to do the conversion from a nonlinear to a linear form. So it just depends on the situation, or depends on the problem. So it's easier to put it as a case study. So for example, let's talk about question C. You see that the given variable over here in the question C is that between y and square root of x. So it's not between the y and x. It means in this context, the straight line relationship is not between y and x, right? The straight line equation is between y and square root of x, which it's easier in my opinion that you put it as y mx plus c, but then like the new variables, the capital Y and capital X. So in this case, the capital Y is still the y, but the capital X is the square root of x. So it's something that you have to be careful. But the gradient is a gradient, constant is a constant. So you can calculate it like the normal gradient or normal constant. So finding the gradient is just rise over 1, same thing. 6 minus 3 over 5 minus 2, 3 over 3 equals 1. So that means you will get y equals x plus c, right? Or that means that will be small y equals square root of x plus c. Now, how do we find the value of c when you already know the gradient? And now it's just a matter of the c, right? You know the straight line equation roughly, how it looks like. Just the same like sec 1, sec 2. Take some one point that is passed by the straight line equation, right? And then you substitute the values. So let's do the same thing over here. Let's say I'm taking 2, 3 over here. So I got the 3. Now the tricky part is this. The question for you to answer. Is the 2 representing the square root of x, or the 2 is representing the x? 2 equals x, or 2 equals square root of x? So that's the question that's really important. How do we know? So we go back to the graph. The 2 is related to the square root of x, not the x. So it's a common mistake that some people still do. So here, that's why it's not the square root of 2, but instead it's a 2 plus c, which then will give you c equals 1. Therefore, you get the equation as y equals square root of x plus 1. So you can do it again for the other questions before I go on with the word problem type of questions. So let's say I'm using the number f example. So same thing, y equals mx plus c, but in this case the capital Y is small y, same. The capital X is actually ln x. So first thing first, find the gradient. 3 minus negative 2 over 3 minus 7, so it's a 5 over negative 4. It means I got y equals negative 5 quarters x plus c. Then same thing, I'll plug in the value. 3 equals negative 5 over 4 times 3 plus c. So I got 3 equals negative 15 over 4 plus c. So c equals 27 over 4. It means y equals negative 5 quarter x plus 27 quarters. Or if you want to put it in the original form, that will be small y equals negative 5 over 4 ln x plus 27 quarters. So then it's a matter of whether you want to put it as an original form, like in the case of this. It's pretty original already. But if the y is not the y, let's say the y is not actually also a ln y or y squared or something else, then it's better that you change it again, but then again depending on the situation or the application or the question simply. So let's move on to the word problem type of question over here. So let me make it a bit bigger first so then you can see it clearly. So let's see. So in this case that we have variables x and y are related so that when the e raised y plotted on the vertical axis, so it's like this, e raised y, and then x squared is here. A straight line graph passing through the points 3, 4, let's say 3, 4 here, and then 8, 9 here. Let's say something like this. So let's say 8, 9, 3, 4. Let's say something like that. I don't know whether it's correct or not though. So question A, express e raised y in terms of x, and then in question B, express y in terms of x. This one will be simple. So question A is the key. So if you can do question A, B is just the transformation. So it's best, in my opinion, again, to put it as y equals mx plus c first. But then you know the capital Y is actually the e raised y. The capital X is actually x squared. And then, again, find the gradient. So 8, sorry, not the 8. The 9 minus 4 over 8 minus 3. So you got 5 over 5 equals 1. So you got y equals x plus c, and then you plug in again the one of the points. 4 equals 3 plus c, so c equals 1. So pretty simple equation it turns out. Y equals x plus 1. But again, we know that the y is actually e raised y. The x is actually x squared. So here it is. This is the answer to question A. In question B, because they want us to answer in express y in terms of x, so what we need to do, how can you convert an e raised y into just a y? Correct. It's using logarithm, but then in particular, we should be using ln. So it will be ln of e raised y equals ln of x squared plus 1. So you can apply ln to both sides, or you can just simply convert it using the definition of logarithm. So you have y equals ln of x squared plus 1. And then you're done with the entire problem. So you see how it works. You see how we are converting from the nonlinear to a linear, but then it must come from a particular question first. So it's like, is it really converting linear to nonlinear or nonlinear? It's sometimes confusing, but as long as you can tell the relationship between the two, how you play around between the two, so I think it will be good enough. So again, this video and the previous video, but the conversion from a nonlinear to a linear, there are two basics for you to go through before you actually go through with this one. So you might remember where this video comes from. So again, better you go with this, and then if you can't really make sense of why it works that way, you can go through this video again for this section in particular and this section in particular. Okay, so that's it for the chapter 7. I hope that it makes sense, then it can help you further in understanding the chapter. All the best.